Okay, so in the problem they tell you that the wheel goes 200 reps per minute in 0.75 seconds. So what I assume from that is that the final angular velocity would be 200 reps per minute. The initial angular velocity would be 0. The angular acceleration is, we don't know, and the time is 0.75 seconds. So the first thing you need to do to calculate angular acceleration is you need to use unit analysis to convert 210 revs per minute into radians per second. So once you do that, you get that 210 revolutions per minute equals 7.0 pi radians per second. And then to get the angular acceleration, you use the formula final velocity equals initial velocity plus angular acceleration times t. And you use that because you know the final velocity, you know the initial velocity, you are solving for angular acceleration, and you know t, so it's an easy way to get angular acceleration. So once you plug in all your values into the variables, you get that the angular acceleration is 29 radians per second. And that's for part A. Part B, they asked you how many revolutions did the wheel make. And in order to find that, you have to use this formula because you don't know what final theta is. So you have to solve for final theta, which is the best formula to use to find that. And you just plug in all your values again. 7 pi radians squared equals 0 squared plus 2 times 29 radians per second squared times theta final. And then you solve for theta final, and you get that theta, the final theta equals 8.34 radians. In order to convert radians to revolutions, you have to divide by 2 pi because 2 pi is 1 revolution. So when you divide 8.3 radians by 2 pi, you get that the wheel went 1.3 revolutions. And for part C, they ask you to find the radial and tangential components, and they give you a new speed, which is 180 revolutions per minute, and they give you the radius, which is 12 centimeters or 0.12 meters. So just like in the part A, in this part you also have to convert revolutions per minute to radians per second. So after you use unit analysis to do that, you get that 180 revolutions per minute is 6 pi radians per second. So to find radial acceleration, you have to use the formula. Radial acceleration is equal to angular velocity squared times the radius, and then you just plug in your you just plug in your values, and you get that the radial acceleration is 43 meters per second squared. And then for the tangential acceleration, you have to use the formula, which tangential acceleration equals angular acceleration times the radius. And you get, you have to plug in your values, and after you plug everything in, you get that the tangential acceleration is 3.5 meters per second